Hello and welcome to this Mastering the Machine webinar for the 29th of January 2022. The topic today was maintenance and troubleshooting, and in particular my new book, which is titled Maintenance and Troubleshooting in Industrial Automation. I didn't really have any guests today, but a couple people joined me. Al Abrams, I haven't talked to him for a long time, and Dan Ryken, who has attended several of my events live. So we had a really good time, and I hope you enjoy it. Hello, everyone. Welcome to this Mastering the Machine webinar for the 29th of January 2022. So far, I am the only one here, but I may be the only one here for the entire webinar. It is Saturday morning, coming up on 10 o'clock, and I actually don't expect a lot of people to show up for this, but this is an opportunity for me to talk about my new book, Maintenance and Troubleshooting in Industrial Automation. So should be sharing the screen. Of course, I can't see myself, so I'm just going to go ahead and start here, and I'm going to start it the same way that I normally do. I am going to call your attention to something on the screen here. This is the new logo for NTH University, which is Automation NTH's internal and external training program for customers and for their interns and engineers. So I just got this. You'll have to let me know in the comments if you like the concept of it, but this is something that's going to be appearing on my new book, and I'm probably going to rebrand a couple of my old books with this same logo. In any case, currently Saturday morning, so not a lot of people probably logging into this. What is Mastering the Machine? This is named after a document that I put out back in 2013 called Mastering the Machine, and it's kind of a little write-up about how machines are specified, how machines are priced, that sort of thing, step-by-step guide to planning, machine building, and documenting. And I just named this webinar after that document, since it is about kind of systems integration and that sort of thing. So you can download this if you're interested in it at either one of my websites, automationllc.com or automationprimer.com. It is kind of evolved into a training and automation website that includes these webinars with the same title, and you can find the access to that website here. We have a few members that sometimes come in and check out my webinars, but we do these every 2 weeks. So what is the Automation Academy itself? This is a website that I built a little over a year ago, and it has a lot of training videos for Allen Bradley, Siemens, Omron, things like that. And it really started as a PLC training website, but it's kind of evolved into more of a systems integration website on the advice of a lot of the people that have joined. So that's kind of where all that came from and where this webinar came from. And we do have a library in there, lots of documents, technical documents, software. There is a community there with some interest groups, and of course we do these webinars every 2 weeks. So enough of the advertising. These are the previous books that I have published, and this newest book, of course, is on the subject of maintenance and troubleshooting. So I'm kind of calling your attention to these old books and kind of show you where this all came from. Back in 2013, I published a book very similar to what this maintenance and troubleshooting book was, but it was a general discussion of industrial automation. And it was called Industrial Automation Hands-On. I didn't have a lot of control over what that book looked like. So McGraw-Hill is the publisher. They own the content of that book. They say I can use up to 10% of that book for advertising of the book and things like that, but I really don't have a lot of control over what's in it. It is a black and white book, even though the color here is colored, but the contents are black and white, and it was really intended to be a textbook, even though I didn't write it to be a textbook, but that's what they said it was supposed to be. But one of the problems that I had when I wrote that book is I didn't put any quizzes or test questions things like that. And when I talk to college professors about what a textbook really is. They said, college professors are lazy and they're not going to write their own test questions or actually read your book. They want you to have all that there. As a matter of fact, they would like you to have an instructor's version of the book and that sort of thing. And that's why college professors generally write their own books, right? They're experts at what they're teaching, and that's how they write their books, and they put their own test questions and things in there. The next book that I put out was a kind of a simple PLC hardware and programming book. And I called it PLC Hardware and Programming Multi-Platform because it was meant to be generic. And I didn't know a lot about publishing at the time. So I connected up with a what they call actually a vanity publisher, which is Author House. And what you do is you pay them and they'll put out a book for you. You own all the content of the book. And so I can publish it somewhere else, and I'll talk a little bit about that later. But you can see I actually put my company logo on the front, and I really meant it to be a training manual for classes. One of the things I realized, I made it generic, but when I made it generic, I often had to print other documents like Alan Bradley stuff or Siemens stuff, depending on who was reading the book and what the class subject was. So it didn't turn out to be a great idea to publish this book that way. I paid them, I think they originally quoted me somewhere around $2,500 or something. And I talked them all the way down to about $800 to publish this book. And I have probably made the $800 back, but I haven't made a lot on it because they're the publisher. So they get what they call the publisher's cut of the book. So I kind of abandoned this, and I don't keep these. I don't use them anymore. But oddly enough, this company Dexcom does use these for their internal training. And I'm going to kind of get to what that means in terms of my new book here. This book, actually, I republished this. I learned something about publishing and decided to include this middle book in this final book, right? Advanced PLC Hardware and Programming, and actually made it the first third of the book. And I published this myself. I actually put my logo on the back of it, and it's about 3 times the size, about 300 and some odd pages, and includes this book. And I do a little better on this, and I can lower the price. And honestly, I don't even sell this, although I do use it for my own classes. I stock these. If somebody wanted one, I could, of course, send them one, but it's really a pain to fulfill orders for books. So that's kind of the history of these books. So my newest book, oddly enough, coming out right every 3 years, 2013, 2016, 2019, this is the latest one. And you'll notice the logo that I put on the front of this appears on this book. And that's because I've started working for Automation NTH 2 weeks every month, very flexible. I can work whatever days I want to, but they have a lot of interest from their biggest customer, which is Dexcom. Dexcom is a life sciences medical device manufacturer, and they have been kind of hitting Automation NTH up for a troubleshooting class. Their machinery is quite complex. It uses things like safety PLCs, IO link. It has machine vision in it, very complex safety circuits. So it's kind of hard to troubleshoot those machines. And they had already been taking PLC training, and they used this book for the PLC training. But like I said, I don't sell this book anymore. So they're having a hard time getting this book because the only ones who could sell it is either the publisher or anybody who carries it on Amazon. And they want like 50 or 100 copies of the book. And I don't carry the book anymore. The publisher could sell it directly to them, but they would have to set themselves up as a bookseller. And that's really not what Dexcom is a bookseller, right? And so they've come to Automation NTH and said, we want copies of that book. And NTH says the same thing. We're not a bookseller. Maybe Frank can do it. Well, I'm not a bookseller either, and I would have to order these and stock them, and I really don't want to do that. So one of the proposals I made was to do the same thing with that middle book, republish it as just a little document, and put the logo on it, make it NTH's logo, or even put Dexcom's logo. But again, they're not really a book company, so I don't know if they'll even allow their logo to be on it. But anyway, so I just got this logo. Again, let me do a close-up of it. It looks like this. It says NTH University on it. And I'm going to explain what NTH University itself is, because it's a big part of my newest maintenance and troubleshooting book. So anyway, we'll have the logo on it, and I'll probably republish this advanced hardware and programming book also with the logo on it. Should be out within a month or two. That's the goal as far as this book is concerned. Let me see what else we got here. Okay, so now it's time to actually show you kind of what is in this book. It's on the subject of maintenance and troubleshooting, and much of the content kind of came from this list. This is NTH University, what their courses look like, right? They have intro to controls and PLCs, HMIs, Logix 500, controls design calculations, things that you would use as a beginning controls person. And then all of these 100 level courses, their interns go through these, right? So they have an internship where they'll bring students in from school in their final year of school, usually, and those would be the interns, or they bring people in that have already graduated from school, and they put them through 4 months of training. That training includes learning general controls, PLCs. They go into the panel shop and they build control panels for at least a month. They use AutoCAD to learn controls design. So they learn how to lay schematics out and how AutoCAD works, things like that. Then they design their own panel, build their own panel, program their own PLC, and the platform, PLC platform, they alternate. They change between any kind of PLC you can think of. So sometimes they may get Modicon. They've done PLC Next. The guy right now is doing B&R automation. It's kind of interesting, a B&R controller, and somebody else has already done the B&R, but they've done Mitsubishi and Omron and even a building controller of some kind. So they do all kinds of interesting projects like that. Once they get out of the internship, and once they're hired, there's customer service for engineers. That's a pretty important topic. They go to some 200 level classes, controls design calculations. How do you figure out full load amps, things like that, intermediate controls design. Even though I'm at Automation NTH and I help with a lot of this, I don't really know what's in all of these courses, right? But they have to do with training an engineer to be a better engineer. That's the general idea behind it. A lot of vision system stuff, insight spreadsheets, et cetera, robotics, SQL. They use a lot of Ignition there. So of course, Ignition has Inductive University. You can download Ignition software and learn it yourself, get certified in Ignition without taking any of these courses. And they do a lot of advanced vision systems because they're doing medical devices. They do deep learning what do you call it? Artificial intelligence kind of vision systems. And they use this VIDI to do that. So pretty deep stuff. And a lot of this, what I did is I went through my table of contents and related the table of contents in this new book directly to these courses. I said, what is in their courses that I'm going to put in my troubleshooting book? Because that's what Dexcom is going to want. They're going to want to troubleshoot the things that these engineers build. So you can see here, I've got some mechanical things. They don't have a lot of courses on mechanical, but obviously if you're troubleshooting equipment, you need to know a lot about mechanical systems. You need to know about power transmission and motors and bearings and gears and some of those things. And this is not meant to replace university training, right? There's already books out there on different mechanical things. And this book is meant to be a kind of a thing that captures a lot of what you would see in industrial automation without going into full detail on everything, but giving somebody enough knowledge to go and figure out at least what they have to learn, right? What are some of the terms and things like that? So this is the table of contents. You can see here, I'm actually close to the end of the book. A lot on machine vision here. PLCs, I put a lot of the PLC stuff I already had in here. A lot on systems, what kind of different machines, CNC machines, process control, converting. A lot of people don't know what converting is. You don't learn that in college. So this is meant to be kind of go a little bit beyond what some of the people that learn in college covers. HMIs and SCADA, of course, you can download things like Ignition and do that. OEE, right? Calculations for OEE, for those who don't know what that is, operational equipment effectiveness. This is something that sometimes maintenance people have to get involved in. And then I get into a lot of the troubleshooting. And these are the topics that I use in the troubleshooting section. Then I start talking about tools, techniques, and I go into great depth taking a specific machine apart at Automation NTH and going through the schematics and all the physical parts of the machine and explaining what they do. So I used a machine called the Sweep machine for this, and there's a lot of pictures of it in the book. So at this point, I'm going to drag the book itself over here and show you a little bit about what I've been working on. This, beginning part here, of course, there's going to be a nice fancy cover and all that, but this page is the same as the page that I did on the PLC book. So now that I've published a book myself, I'm able to use more or less the same kind of inside cover sheet, right? The same little blurb in here with the year. I'm the publisher, so I put my own company on that. Leave the page blank because this is actually the back of one of the pages. It automatically creates things like the table of contents, right? As you update things and make headers, it adds all these items. You can see here that there are a whole lot of exercises. That's, again, one of the things I learned when I published my first book. If you want this thing to be a textbook, you really need to put some exercises in there. And what I do is I put the answers at the back of the book. Why? Because I don't want to publish a separate book with the answers in it. Some instructors have said, well, if we want to use your book, then the students have the answers for the quizzes. Well, use a razor blade and cut it out. That's why it's the very last section of the book. You can just razor it out, but I don't have the ability to really publish 2 copies of the book. So what is in here about troubleshooting, right? I said this is partially in response to a request for a troubleshooting course from Automation NTH. And my title there is lead trainer, but I already used to contract to them and do training for them. It's just a little more formal operation now. Jeff Buck is a vice president there, and he approached me with the idea of creating a course for troubleshooting. And I'd done classes of these, and they used my old book. But as I said, I don't have control of that old book. It's a McGraw-Hill book. It's pretty expensive. And unfortunately, it's also black and white, which, for automation is kind of tough. We use a lot of colors in automation. So this book, of course, I have a lot of colored pictures and things. And so this is just a little blurb at the beginning, talking about what the book's about. I mentioned here that if maintenance is thought of in terms of a battle or war, right? You're fighting to keep your equipment, up and running. There's a strategy that you use to approach how this battle and future battles are fought. There are the tactics that you use to accomplish the strategy. That would be some of the formal troubleshooting and things. And then there's all the tools that you would use in achieving the goal. Now, this book has evolved. It's got kind of more than just maintenance and troubleshooting in it, but part of my goal was also to make this about the same size as the original book. Let me see if I can make this a little bit bigger. We'll zoom in just so people can see it a little bigger. We'll make it, how about 125%? See how that way, 120. See how that looks. Okay, so now you can read it a little bit. I use some of their colors in here. What is NTH University? I explained that. This company is, you would just type in www.automationnth.com for those who are looking for work. This is a pretty high-tech company, very good working culture, and they're almost always looking for talented people. Unfortunately, for those of you who are overseas, you really have to already be in the US. You would have to physically interview with them, and they're looking for people that are, like I said, they have a big UL panel shop. They have people that they don't do machine assembly. They actually partner with other companies that build the mechanical part, and they contract them. So they have these certified automation partners they use to build the machinery. One of them is Alpha Integration, which has a building right across the street from Automation NTH. They're kind of evolved into having some very big buildings here. And they go over there and they build all the mechanical parts. They build these flex bases and things. And then Automation NTH does all the design and controls and fabrication and things for that. So anyway, this is a little blurb about that. And then I just mentioned that this book helps in supporting their NTH University program, which is why I have the logo on the front. Talk a little bit about maintenance strategy, learning prerequisites that are required to successfully maintain equipment, which a lot of people will know a lot of this. And I'll say, well, if you already know a lot about this subject, skip ahead in the book. There'll probably be something else in there for you. I mentioned, of course, this is if there's errors, omissions, or damages arising out of the use of this information, not my fault, right? Don't use this as a Bible. This talks about some of the different kinds of maintenance. Sometimes people work in a plant and they don't know how the management of the maintenance and how the systems work. So I described some of the acronyms that are used in maintenance. MRO, people hear that and they don't know that it necessarily stands for maintenance, repair, and overhaul. A lot of the types of maintenance that fall under this are like preventive maintenance, corrective maintenance, predictive maintenance. Those are pretty easy to figure out what they are just by the titles, right? Periodically inspecting and servicing equipment, planned or scheduled maintenance, condition-based maintenance, when, hey, there's a problem, that thing's leaking oil, let's go fix it. Corrective maintenance, when something breaks down unexpectedly. That's probably what most people think of. Hey, that machine's down, we got to go get it up again because they're losing $10,000 an hour. Talk about that. And then predictive maintenance, which has to do with, this motor has so many hours on it, it's time to replace the seals or bearings, service the bearings or something before it breaks down. So that would be another kind of maintenance. So, and then I have, again, a little quiz, and I talk about CMMS systems. You can buy software that plans, schedules, all that. It's kind of neat stuff. You can go find those online yourself, right? So then I ask, what are the three major types of maintenance? The answer is right there above right above you. So there's no real difficult questions in here. There are some calculations for those people who don't like math a little bit later. Which is the most expensive type of maintenance, right? Well, that would be the corrective maintenance, because when things break down, hey, your line's down, you're losing a bunch of money and you're having to replace something, probably with something else new, right? And then what kind of software can be used for that. So very general stuff there. The machine and system theory, this is kind of looking at a machine and telling what's wrong with it. And I would even go farther to say, a lot of times you can look at machinery and tell what it does. This week, I had an interesting experience. I was called by a company about 500 miles from here in North Carolina. And they had a guy who was their Siemens expert, and he actually died of COVID, believe it or not. So they suddenly had no Siemens support, and they had a machine that really needed work on it, maintenance and upgrading and that sort of thing. And this guy had been involved in it, and suddenly they didn't have anybody to do that. So they called me up. I went out there for 3 days and we worked on that machine. We did a lot of Siemens training. And I didn't know how the machine was, supposed to operate, but you can go look at it and you can tell a lot of things. In this case, there were trays and there were these little aerosol containers, and it just palletized all the aerosol containers. And turned out what they do is they palletize the aerosols after they make them. They put them in a warehouse for a week and make sure they don't leak. Bring them back, test them for leaks, run them back through the machine, repalletize them, put them back on trays, put them back in for another 2 weeks, rerun it through the machine, test it for leaks again, and then it's released to the public. So at the time that all these little aerosol nose sprays or whatever come out, they have been through 3 weeks. It's almost like aging whiskey, I guess. It's kind of interesting. But this whole palletizer and depalletizer system, that's all that did. It's just a Siemens machine, and it put things on trays and took things off of trays. And then we're having a problem several times a day with things not counting right. And we kind of got in there and looked at the code, looked at the physical part of the machine, and debugged what was up with it. And now they're very comfortable with it because they can get online with the machine. They can read all the schematics that are there and tell what things are. And hopefully we'll document the machine a little better now that I've been out there and kind of written down a lot of things for them. So that's kind of what this is about. Observation, watching a machine in operation is one of the best ways to learn how it works. You can't always do that. The machine's not always running when you're looking at it, but how does the product enter and exit the machine? What's done to it as it's processed, right? So these are questions you would want to ask yourself. Take notes. I'm a big believer in that. Write things down. The time to learn your machinery is before you have a problem, right? You want to watch it in operation before you ever get to the point where you have to fix it. Visual signs of problems, easiest to find, leaking fluids, things like that. Thermal imaging, that's kind of a visual thing. You point a camera at it and you can see where hot spots are. You can listen to machines, listen to the sounds they make, right? Grinding, high-pitched squealing, those kind of things cause problems. Smells, you can smell burning rubber, you can smell burning oil. So this isn't really meant to be a troubleshooting tip so much, but it is a, how can I check out the condition of the machinery? Very simple stuff. And I'm only on about page 16 here, and I think 5 or 6 pages are just table of contents. Then I start talking about the products and types of machinery, and I go into much more depth on that later. Knowing about the product being processed. Well, hopefully if you're working for a plant, you're going to know a lot about your own product. You're going to know how it acts in the machinery. And then I do cover later the classifications of machinery. And I talk about packaging machines, robots, pumps, conveyors, material handling machines, things like that. And then this exercise really, this comes from a lot of times when I do PLC classes, we have something that says, you know, what do you make in your plant, right? What does your process look like? And this is meant for the person to just keep records and answer themselves. And sometimes we talk specifically about, hey, are you here to learn oil and gas, you know, processing, or are you here to learn automotive manufacturing, or are you here to learn chemicals or FDA validated, pharmaceutical or medical device equipment? It's all different. They all have different rules and things like that. So this is, there's no correct answer for this. Are your products consistently the same, or can they vary depending on the process? Lots of interesting questions there, but this doesn't have an answer in the back of the book, right? You can't look up the answer to what your machine produces. Does your machinery require a person to operate it? Often, even if it's an automated machine, there is a machine operator there. So that's where we get into later, talk to the operator to get some of your information. Do you have an operator interface or HMI? Do you know if that operator interface is an HMI or is it a computer? Because the implications of that are very different. And then list some of the characteristics of your machinery that can be sensed visually. Lots of stuff. Documentation. What kind of documentation would a machine have, and what can you learn from it? So that's what this is. Talk about exploded parts views, replacement parts lists. P&IDs. I noticed that Dan Ryken's on here. I think he probably deals with P&IDs if he's in the process industry. PLC programs, studying that. So I do go into more depth on some of these things. And again, there's no correct answer. What are some of the documents and programs you have that would be appropriate for diagnosing problems on your machinery? Then I start going into some more technical things. What is a powertrain? What are some of the mechanicals, things you need to know, right? Power transmission, bearings, just a simple grease fitting kind of thing there. Now, I'm not going to tell people how to grease a bearing, but there is a fitting here. You're going to learn more about that in the maintenance manual for your machinery. Hopefully it will show you how to do a lot of that. Gears and pulleys and motors, very brief stuff. This is something I run into a lot, is broken couplings, right? This stuff I mentioned is generally inside of a housing, right? So you kind of have a hard time getting at it, but this is the cause of a lot of the problems I've run into: broken couplings, slipping couplings, your encoders will get off, and that sort of thing. Talk a little bit about seals, clutches, mechanical adjustments. So this is very general. Ventilation, go into some of these things, and then have some simple questions, right? Some of the possible failure points in this blower picture, pop-up diverter. These actually do have a list of things that I put in the answers at the end. By the way, it would take a long time to go through the whole book. This is figure 5, and there are now 300 and some odd figures in this book. So this goes on and on and on. And then I start getting into pneumatics, talk about some of the mechanisms in the pneumatics, do some calculations, how to calculate force. Most technicians don't necessarily have to do this, but this is a design help thing, right? Calculate the force for a 1.5-inch cylinder at 60 PSI. It's just F equals P times A, but there's more to that than, you have to calculate a lot of things. There's pi in there and things like that because the surface area is round. You actually have to subtract the surface area of where the shaft joins the piston. I kind of mentioned that in passing here, but I don't go into great detail because, again, not really a design class. Talk about flow controls, put some helpful things in here, talk about the symbols for different things, mufflers. I had to stick that here at the end. This is actually from one of my previous books. This is an easy way to read pneumatic symbols. This is kind of a tutorial on it. What do all these different things mean? I go into a little more depth and actually show how these things move back and forth across. And I've made videos about these before, what these arrows mean, what these ports mean, right? And then there is a more in-depth pneumatic diagram that I plan on putting in the back. And then here, this is a simple diagram that uses a valve, and you can kind of talk about how this shifts back and forth and it energizes some of the different ports. So, lots of pneumatic stuff. I actually have a physical picture here, talk about what the different parts are, shutoffs, filters. I go into great depth on the specific machine that I use as an example for troubleshooting at the end of the book. Talk about filters and regulators. Sometimes people don't get this in college. Lubricators. I mentioned the fact that we don't use a lot of oil lubricators anymore because it just really cruds up your air system, right? And again, there's a lot more of this available online. You don't have to take this as everything, but I do talk about all the different things that might require attention. I'm going to kind of breeze through more of this. There's a little test question, right? What do you think this thing does? You can look at these valves and you can see here that this is something that kind of supplies itself. Here's a cylinder that comes forward and hits this, and it makes this circuit actuate. And I'll let you be surprised when you look at the answer in the back to tell what it does. So there's 4 valves here, and this is obviously an automatic kind of symbol here. And then some simple questions here. What type of valve might be used on this pusher cylinder? There's several right answers there. Talk a little bit about safety, make somebody do a calculation. I do the same thing for hydraulics. I actually looked online for a good diagram for this. I couldn't find one that had everything I wanted, so I had to draw this myself. The ones I found a lot of times didn't have an oil cooler in it. So this is a kind of a sample of a lot of things you'll find, but people who are a hydraulic expert will find other things to put in those systems also. So talk about lots of that, talk about the difference between hydraulics and pneumatics, right? Why would I use one over the other? What's the biggest cause of failure? Then I go through electrical. Now, this was something, the reason I put some of this stuff in here is because sometimes I get people in classes that haven't had electrical training, and I need to at least put the basics in here and how resistance and some of that stuff works. And you can go in here and, of course, get a lot more in-depth training, right? But I want people to understand what the symbols are. And if they're straight out of high school and they haven't had electrical training, this will give them a start. And I do, again, some simple, some very simple calculations and things here a little later, show people what some of the symbols they would find in electrical diagrams for solid state devices, things like that. Chips, right? This is actually an inductive prox. People don't realize there's actually a little processor in a lot of proximity switches. And so this thing just does some switching. And you can get very complicated for some of those little circuits. So again, another little test. I think there's about 40 probably exercises in here. Go through basic electricity calculation, series parallel without going into great depth. Again, it's just meant to be a quick tutorial. Go into AC, explain what that is. Talk about 3-phase power, explain what that is. Explain the fact that when you get a voltage on AC, what you're getting is the effective voltage, right? You're not getting the peak voltage. So you can have actually much higher voltage at the peak of your electrical circuit than you're actually reading. But your meter is going to say, 480 volts or whatever. That's going to be kind of the effective average voltage across those phases. Then I go into digital and analog, which probably most people already know. This is, again, out of my PLC book. I talk about resolution. What does 16, 14, and 13-bit resolution mean? In most cases, PLCs, it means the values will jump by 4 or 8 or something like that for each increment. It'll go to the same value of 32,000 something, but it may jump by little increments, and that's what the resolution means. And explain all that. Talk about RS 232, 485, things like that. There's a pretty good, I do serial here, but I also do a pretty good Ethernet model in here. Went into a little more depth on Ethernet than I have in my previous books. Talk about a lot of the different, what are all these things? What is a NIC? What's CIP? What's a hub or a bridge? So some definitions. Talk about IP addressing, class A, B, and C networks, how those are built up. So a lot of times people type in their IP addresses and they don't know where all this comes from. Talk a little bit about industrial protocols like Profibus. Mention pinging. Sometimes I mention somebody needs to go ping something and they have no idea what I'm talking about. What time we got? About 35. What else we got in here? I'm only less than a quarter of the way through the book, so I'm going to get to some of the more fun parts. Lots of stuff on numbers, right? We need to know BCD and things like that, data types, double integers, etc. Talk about devices, relate the physical device to the circuit drawing for it. Talk about sensors, right? So this, I've kind of skipped ahead here, but talk about proxes, how they work, Hall effect sensors, how are they different than a prox, the different kinds of photoelectrics. You can find most of this in your catalogs. I found one of the best ones was Omron. Omron had an awesome sensor tutorial right there in the catalog. So you can learn a lot of this stuff for free. You don't have to buy a book to do that. M12 connectors, some of the different sizes. I kind of threw this in here at the very end. Talk about M12s and M8s and what the different configurations are. Can't just buy any M8 cable and expect that it's going to mate up with your proc switches and things. And then lots of questions. What's the most reliable type of sensor, that sort of thing. Talk about the wiring, right? This was out of my old PLC book. What is syncing and sourcing? That's always very important. Special purpose sensors went into LVDTs and load cells, thermocouples, a lot of different kinds of things in here. There's a nice, I think that's a multiple LVDT picture. This was a project I did a long time ago with LVDTs measuring something. Encoders, how do encoders work, quadrature, etc. This is a resolver, which is sort of like an encoder. Barcode readers, go into that a little bit. Then I start getting into, I think, machine vision somewhere in here. Talk about sensor troubleshooting, barcode troubleshooting. Probably having a known good part. I mentioned that at the end of the book. I go over troubleshooting itself for quite a bit. Instrumentation, I kind of stuck this in at the end because even though there are a lot of I&C books out there, for the people that work in the manufacturing industry, they need to know what instrumentation is, what an instrumentation technician is, which is not what most people are when they go into a automotive plant. They don't know what an I&C person is. They don't use these loop controllers. They don't use flow transmitters and things like this. They use more discrete manufacturing things. So I go into more depth on PID, how to set up PID. There's a couple good tips in here, how to start out to figure out how to set your parameters. I have 2 different methods of doing that in here. Modifications to parameters, what they mean. What is a closed loop system? Very basic stuff. Go through P and ID. So sometimes people hear P and ID and they think I'm talking about a PID. No, that's a different thing, right? Piping and instrumentation diagram. This is not, it doesn't cover everything about these, but it does give you the general concept of what a lot of these letters and things mean and what a lot of these shapes mean. You're going to see these, and then I give a couple examples, right? There's a very simple, just a tank kind of filling another tank. with a bunch of little symbols on it. Explain what some of those things mean. Valve symbols, some very generic stuff. This was machinery that we built at Wright Industries that was actually not process control, but they forced us to write P&IDs for machinery, which was very unusual, right? You didn't have symbols for a lot of these things. So you just drew a big box with this took mortars, and it took the nose cones off of the mortars and extracted the energetics, actually drilled a hole in the little nerve gas containers inside. So as you can imagine, human beings can't go into this machine. This all had to be done automatically. Safety systems. Now this I went into pretty good detail on. I went class 1 through class 4 safety systems, talked about the performance levels and how people classify safety systems, talked about the history of where a lot of these things came from. We used to use MCRs like this, and you can't do that anymore. This is an old single channel, and in the 90s, this was what I dealt with. You didn't have dual channel systems back then. Then they came out with self-monitoring start-stop circuits with interlocks and things. They were still single channel, and then they started getting into dual channel, category 2. And so I did some of the basic diagrams here, then showed a category 3 system with guards, and I go into much more detail on this at the end. So I'm going to show you kind of at the end here. I will probably skip ahead here a little bit. Category 4, talk about what those are. Safety system components, some of the different things you'd see, direct opening, interlocking, input components, etc. More on category 4, dual channel, right? Ask lots of questions about it. And then, like I said, there's a lot more on this at the end. Motor control, starters and overloads. How are they wired? Go through just some of the diagrams and things. This is a soft starter. Right, this is something that brings the current up slowly rather than just slamming it in. Then I get into a little bit into VFDs and how that works. Little here and there. And I use a PowerFlex 40 as my example and go through all the wiring of this. Go into how the PLC commands, right, directly control this, because a lot of times you don't wire your controls into your drive. You just use commands. You'll use Ethernet IP or something, and then there's a physical drawing of the front accessible controls. You can just push the buttons on them. And we may create an exercise using all this that people would do hands-on for that. Then I get into motion control, right, servos, that sort of thing. And you can see this is kind of building, getting bigger and bigger. And then I combine the servos together and make a system out of them. Sometimes vision guided servos, coordinated motion, and then cover robotics a little bit. So you can see this is a kind of a general book covering a little bit of the details of a lot of general subjects. Talk about a work cell here and how all these things have to talk to each other. Right? There's not like a single controller that controls everything. It all has to talk to each other. And then we're getting into the fun part here pretty quick. Oh, machine vision. I do a very simple intro to that. And this is meant actually for plant managers and people like that who don't understand what machine vision is. They think you magically put a camera on something and it inspects it and it passes or fails it. This goes into a little more details. Was kind of proud of this when I came out with it. It just puts things in terms of having an analog photo eye and then multiplying the photo eye across many, many pixels, right? This is the way vision works. You can see here, there's just a little piece. There's a little farther view. There's a little farther view. And by the time you get done, you can see that we're just looking at this little junction. And this is actually what they call the region of interest for this, right? So this is an old application I did to tell whether a cap was on here tight or not. And this was an old 640 by 480. Now vision systems have much more resolution. So that's the basics of it. Then I get into lenses and field of view, depth of field, calculations, parallax, a little bit on everything. And then I go through, lighting, lots on lighting, different types of lights and the advantages they can bring in. Different types of cameras, smart cameras. You may have seen these, Cognex, very famous for these. Processors with multiple cameras on them. Keyence is very popular in this area, or computer-based systems, right? This is, if you go to the vision show, you'll find a lot of this. like Matrox and things like that, computer-based systems. Then I talk about pre-processing, the basic tools, how do they work? How do they scan across the images and pick up the pixels to find edges? Here's a nice finding an edge on a line. It's just looking for a light to dark transition across an area. Circular edge tools, same thing. A little more detail on this, gets into a little more advanced vision, right? Finding blob tools, pattern recognition, optical character recognition. And then you would need to get the software, right, and play with it yourself. You can actually get Cognex's software. You can bring in images from other sources and simulate all this on your computer. I mentioned here, this is probably the most important thing. Your machine vision system is almost always some kind of a change in the image, which means either lighting, or maybe the camera got moved, maybe the object itself is not where it should be, lens focus, right? So these are the things that you're looking at. You're not necessarily having to reprogram your vision system. So, and then I ask those kind of leading questions in here, and people can answer all those. So that's a little bit on vision. PLCs is almost directly out of the old book, the middle book, right? So this is a lot of the stuff people would already recognize, how these sensors interface with inputs and outputs. I talk a little bit about various brands of PLCs. I talk about how the bits compare. Here's Allen Bradley, here's Siemens, here's Omron, and here's Koyo. Completely different addressing schemes for all of them. And this kind of goes on and on. I did put a little bit of extra stuff in here than was in my original PLC book. I go over the 5 PLC programming languages. This is almost a dead copy of the original book. Bits and symbols and that sort of thing. So you've probably seen a lot of this before, some programming exercises. And then I actually put some extra stuff in here. I put a little bit of a bit shift from a bottle processing plant, and how is this stuff ejected, and went into a little more detail about that. Describe what all the different types of instructions are. Gave some examples in Allen Bradley and in Siemens. Now there's, again, more on this as I get into the actual troubleshooting part. So this goes on and on, more PLC stuff. Maintenance and troubleshooting of PLCs, forces, how those work, meant to be generic, like my original book was. And then there's a lot of kind of Allen Bradley-esque stuff here, right? I would say it's similar to that. Then I get into machines and subsystems. This is, again, out of my PLC book. The different levels of system communications, machines and subsystems. This is where I get into describing what the different industries are. CNC machines, molding and forming. There's an injection molding machine. There's a press, old press. Used to put my own controls on old Chinese presses, and a company would order those presses, just the body of it. And I would build panels like this off to the side of it, and we'd buy a Parker hydraulic system or something and put that in there and build hydroformers out of them. Material handling, that's a very common one, right? Talk about pick and places and conveyors and maybe dial tables, things like that. Packaging machinery, different types. Talk about a whole system and how things talk to each other there. Converting. This is another popular process control type thing. This is the plant that I work at down in Miami quite a bit. I've done some webinars on this, ABD. This is something that we did for the plant to block diagram everything. This is all the machines that are in there, how they talk to each other. And a few more pictures of that for process control. Since I had access to the ABD stuff, and this is getting into a little more of what Automation NTH does, right? They do more high-tech stuff in clean rooms. So validated software, I had to talk about that, because a lot of times you can't change the code in the PLCs in these places. You have to kind of write the code ahead of time. And then last second, I thought, people like Stephen Gates do a lot of, things in terms of PLC programming and utilities. So I went over a lot more on wastewater and electrical utilities. How is your power transmitted? What are all these stations? And this is where all the little PLCs and remote terminal units are in systems like that. So I decided to talk about what all the different substations are, Water treatment, same thing. How is water treatment done? What are the different stations in water treatment? Lift stations, things like that. So a lot of this is terminology, just explaining what things are. And then talk about a little bit about material handling, things like that. Visualization, notification. I go into more depth on this later again, HMIs and SCADA. Animation, how you program things, what some of the different devices, DCSs, put that in at the last minute. Okay, and then we're getting into some of the meat here, I think. OEE, it's a lot of math, a lot of calculations there. 6 big losses. And when does the meat start? IIoT, I threw that in there at the last minute because a lot of people talk about using that, right, for Raspberry Pis and things like that. We've had some webinars on that. Not really a direct training thing on that, just explaining what it is. I think I even threw Walker Reynolds a bone somewhere in here. IT, OT convergence, right? A lot of these terms that people are using now. Okay, tactics, troubleshooting. This is where I get into the meat of the troubleshooting itself. What are the different formal methods of troubleshooting? Start with a simple, begin from a known good state. Some examples, checklists, split, half split method. I never found a good diagram, so I drew my own on this. Root cause analysis. This is a formal method for people that are into Six Sigma. Ishikawa diagrams, which some people call these fishbone diagrams, so I called it a Fishikawa diagram down here. So that was cute. Intermittent and multiple systems. Talked a little bit about that. And then tools and techniques. A lot of this, I kind of hesitated before putting this in here, but talked about calipers, the different mechanical things that you would use. You know, tools, hand tools, mostly hand tools, some power tools, drill bits, how they work, saws, Home Depot stuff, right? Grinders, etc. Electrical meters. There's quite a bit on this because when it comes down to it, that's what a lot of this book is going to be about at the end here. Talk about some other electrical diagnostic tools, oscilloscopes, spectrum analyzer. There's one of those thermal imaging cameras that we talked about before, detecting heat. So again, a lot of this stuff is available. I threw this in there because I had written a book on building your own control panel, building your own trainer. And I had this diagram in it. So I just imported it in and said, these are some of the kinds of things you need if you're an electrical guy, strippers and things like that. And then put some of the better strippers in here, strippers and crimpers. Had somebody ask about this on LinkedIn the other day. What can people recommend for stripping 22 gauge wire? You know, I can use these. I have it. There's a 22 gauge stripper on this. It doesn't work real well. It's really hard to hold the wire and pull it. So a lot of these things, right, are a little bit better. Some of these kind of strippers here. These ferrule crimpers here, my wife bought these for $350 20 years ago. I think these things are probably $500 or more now. And I went through some of the techniques, cutting holes for HMIs and things like that, pinging things and marking things for panel building, knockouts, Greenlee knockout kit. This is the end of my ferrule crimpers, right? So this thing here is kind of ratcheting. Talk about how to twist this, stick it in the right size ferrule, crimp it, marking, labeling, some of the different markers and labels you can get. And then this is where it really starts getting kind of crazy in here. I started using the example from a specific set of drawings, the sweep machine. This is a trade show demo. This is the one I was talking about that has a lot of safety PLC stuff. And so what I do here is relate, talk about the numbering, the circuit breaker, go to the physical circuit breaker, talk about the labeling of that, relate it to the schematic diagrams, then show the layout in the drawings, talk about what page everything's on, and it just kind of evolves from there. This is the whole drawing package. And then I start getting into what the actual machine itself does, right? There's the disconnect. And it turned out when I started taking this machine apart, they use a lot of IO link. So these are kind of neat. I had never seen these. These are DC circuit breakers, and they're IO link controlled. And so when you trip a breaker, you get more than just the fact that the breaker's tripped. You actually know the current that was going through there. It uses communications to go to the IO link master. And I'm using actual cuts from the schematic diagrams to explain how all that works. So here's just the power section. But as you go on and on, I start talking about communications to the IO link master, and then the IO link master going to some of the other devices. And these are up under the front of the machine. This is the master on the left. There's the electronic circuit breakers, nice close up, all IO link. So there's only one connection to these circuit breakers monitoring everything using IO link communications. And then I go through line by line what page everything's on, because the intent is if I'm teaching this class in person, I'm going to hand the person a full set of schematics for the suite machine. The suite machine has a robot in it. It has a safety PLC, has lots of different connections. These are safety connections. So I go into pretty good depth on how the safety connections work, how the bus works in the background, relate it directly to the electrical drawings. And it goes on and on, right? And then I talk about the safety. This relates back to the safety systems that I mentioned, how safety systems work. We talk about the OSSD functions in pills. Pills is a very common use maker of these safety devices. And it turns out these also are smart devices, right? It carries more than just whether it's on or off. There's actually a microprocessor in here. This is all RFID. It recognizes only its own taught target. So you can't just use any target with this. And then I mentioned all the safety switches in this machine. Go start getting into the safety circuits. And this safety circuit is pretty complex. It has a whole lot of wiring associated with it. So I go page by page, dual channel. And this machine's not actually all that big, surprisingly. It's got a robot in it. You talk about the cable glands, talk about how things are wired into the safety circuits. We're only into the safety part yet. I haven't even gotten into the IO here. Then we get into communications. There's lots of devices on here. They all talk to each other, cameras, etc. This is a web camera. It's kind of a neat feature that NTH puts inside all their machines. They use web cameras to monitor what is happening inside of the machine. You can actually go and bring up archived video and watch what the machine's doing from inside itself. You can look down the conveyors and see the pucks that came by and things like that. Talk about Point IO, which is an Allen Bradley product, right? How does Point IO work? And then start, stop buttons, that kind of stuff. So you're seeing actual pieces of the machine here, pieces of the panel. There's a robot, some servo stuff, how to take this apart. This is an integrated motor. This is documentation you find in the actual drive documentation. So if you needed to work on it, that's the drive. It's an integrated drive, but it explodes into this, right? So you can see the motor and the controller, everything all built into one. How to trace this to different parts of the schematics. Then I go into pneumatic schematics, talk about the valves and how to manually actuate them, and talk about how the controls fire those valves. They're not directly wired. That's all done by communications. There's a little more schematic diagrams. Ethernet coming in, actuating things. Where does the air come into the machine? Where does it go from there? It goes to this nice little FRL and pneumatic shutoff. And that's about how far I am right now. And then I start getting into software, and haven't finished this yet either. So this is at the end of the book, really just talking about some of the different tools. This is all Excel here. Right? You can use Microsoft Excel to build your own auto-generating Excel spreadsheets that will generate code for you. You can take the IO list and generate the software. So that's a lot of what this is all about here. Timing charts. You can make timing charts out of Excel. That's what this was. This is a timing diagram. You fill in the times and it actually builds the timing diagram for you. Then I start talking about CAD, and again, taking pictures, solid three-dimensional CAD. PLC software, go into a little bit of that. Have some pictures in there. Simulation and emulators, that's kind of an important thing. And then at the very end, and again, I haven't finished all this yet. Oh, this is all from ABD. So American Beverage Depot, I do a lot of process stuff down there. So I talked about that. And then I go through this, and this is a picture of the sweet machine. So the sweet machine, despite all its complexity, its job is to dispense lifesavers. It's kind of cool. They built this, this thing that makes it look like these little pucks. And I don't know if I have pictures of pucks, but the pucks go through here, go into the black box, and a bunch of lights flash and things, and the puck magically turns into a roll of lifesavers. So that's what this trade show demo does. But they use something called a flex base, and this is actually what they use to build all their medical device equipment. They stack these things together end to end, and you can use 100 of these in a row, and it will pass parts from one to the other and do all its material handling internally. And each little base will have PLCs all talking to other PLCs. So this is just kind of a neat thing to show what a lot of these do. And then I have some handy charts in here, which are things from my old books too, ampacity charts for speccing circuit breakers and overloads, things like that. It will give you wire sizes versus ampacities, right? So you can spec things. What else? Resistor color codes, good simple stuff there. That's something that's sometimes hard to find. Field of view for vision systems. That's another one. To specify the size of lens that you want to use, depending on how big your object is and how far your camera is from it. ASCII tables. I use this a lot of times for exercises in PLCs to take apart ASCII code. Then I put all the exercise answers in here. So like I said, people can razor these out of the end of the book, and I have to keep up with all this. So I'm not done with the book yet, but I still have, I think 330 some odd pages of stuff in here, but that's what this troubleshooting book is about. I mentioned some of the different types of troubleshooting and things that are in here. It will be a good book. And I actually plan in the Automation Academy, I will pull parts of this book out and just put them in the library, so there'll be a whole section on, machine vision or whatever. Like I said, NTH is kind of supporting me in this. So their courses, I will pull 102, this section out and put it in their 102 course. I'll pull this section out, understanding schematics and documentation, and pull it out and put it in their 104 course. So that's kind of where all this comes from. That's how I'm organizing it. But that is pretty much a look at everything. It is, I've done my hour today. I can see that Dan's on here. I don't know if anybody else has come in. I've just been talking the whole time. Yeah, we got somebody else on too. Let's see who all's here. Al Abrams. Oh my gosh, there's a name from the past. Al and I used to work together, I want to say 25 years ago.
It's been a while.
It has been a while. Yes. We
Yes,
worked
it
at
is.
Roden.
As a matter of fact, I was going to say, I was just looking at a picture on my wall that's got the good old days back when you and I both had hair, or at least I did. I don't remember about it.
I did. I had hair, but I kind of combed it over because I was already losing it. So I like my hair better now, actually. My wife does too, kind of just.
I do too. Hey, it's a lot easier too, right? I mean,
absolutely. Although do you skin your head, or is it just?
No, I still got,
Okay.
I don't,
wow.
I keep it kind of like you. I use the number 2, right? And
okay. Yeah.
Myself.
I use the red one. I don't know what the red one is, but I use a red. I just stick the red one on there. I forgot it one time, and I ended up truly skinning my head and using no attachment, no little finger.
Well, I've got a couple friends that do that. I can't bring myself to do it. It's something about when I was really young, I had a really big head of hair, kind of like my kids have now. And I just can't bring myself to completely shave it. It's denial or something. I don't know. So
what are you doing now?
So about almost 9 years ago, I went to work for Rockwell.
Okay.
And prior to that, you know, when you and I worked together, gosh, weren't you a component specialist for Roden?
Yes, in 1995, and then I left and started my own company in 96. Yep.
Yep. And so I think the last time you and I talked were you with your own company or with Null, or I'm trying to remember.
So that was an interesting thing. I had my own company, but we were the controls department for Null
Okay.
Automation. And I moved my office in the office next to his, and we cut holes in the walls. And I hired ITT tech students, and I would send them over to work on his machines. And, you know, I do all the drawings and the programming for him and stuff. And some of my technicians would go over there and build panels and start the machines up and all that. And then he started doing only packaging machines, and I took over all his gauging machine business. We had done automotive stuff, and he didn't want to do that anymore. So I started doing that, started building small machines until 2006. And then I left. Yeah. Moved here.
Okay. That's right. So, and you and Larry Roberts worked together, right?
Larry worked for me. Yes. And then Larry went to work for Null eventually directly. Yes. He was my first, if you want to call him controls engineer, he was my first. Yeah. Good guy.
Yeah. So what ended up happening was in 2000 and I guess it was 2002. I guess it was probably the same job you had. I was the IC specialist for Roden. And then in 2007, Kendall, excuse me, Kendall Electric bought Roden. I think you probably knew that, but the McCameys sold the business.
With McGraw-Hill, you had to really dot your I's and cross your T's. They were very picky about that. Whereas when I do my own stuff, it's, you know, for instance, this one, I drew everything that Alan Bradley had because I remembered that they had said that. I didn't go back and ask them. But in this book, I have drawings, just, you know, CAD drawings of every product they had, every PLC, so that people can recognize it, right? If they,
sure.
Yeah.
So the one that you're publishing now, this new one, is it going to be through McGraw-Hill too, or are you doing it yourself? How are you doing it?
No. So McGraw-Hill, if you use a publisher like this, I talked about this at the beginning, they own the content, and you can use up to 10% of it for advertising and things, but they also, they give you an author's cut. They did give me a good royalty deposit when I wrote this book originally, but I can't use content out of this book for anything. I can't use it in other people's documentations. This one, the publisher was Author House, but I own all the content. So I republished it, and I learned how to publish it through my own company. So now I'm the publisher here, and now NTH, right? This is the NTH University logo. I'm going to republish this book, and this actually has much of what this had in it, but better. It's more advanced, a lot more modern. Yeah. Okay. But I still can't, you know, I have to be very careful about pictures. Yeah. Yep. I do them every 2 weeks. The next one's, as a matter of fact, I'm going to go ahead and kind of close this out on the screen here. Let's see. There we go. Next one's February 12th. Okay. Guest unknown, right? Guest and topic unknown. So if you're up for it, and I can do it. I put the 12th, but usually I do these on Fridays, but people have kind of mentioned, you know, people work on Fridays. And so then they have to catch them recorded. I'm up for Saturdays too. You know, Saturday morning like this, I've done several this way, and I'm either way. You know, if we thought we'd get more people, Dan's been showing up pretty regularly here. He's being quiet today, but he's been on a lot of these. We had Alicia Gilpin as a guest one time, and I think he likes some of the stuff she does. She's been building, by the way, a turbo encabulator. I don't know if you followed in her stuff. I actually
saw that on LinkedIn. I got a kick out of that.
Yeah, and it's growing. It's just getting more and more, and there's just wires hanging everywhere and different components. It's pretty neat.
That's hilarious. So Dan, who are you?
I'm new to automation, and one of the reasons I tune into Frank is because I hear the wisdom spoken that I have really no other way to access. I can read, certain information, but when it's coming from the voice of a seasoned pro, it reaches me differently.
Outstanding. I mean, so are you working, who do you work for? Are you?
I'm in wastewater right now. My automation skills are dedicated to my own enterprises, Red One Innovations. I've been a student of automation serious now for about 2 years, and I don't know that I'm very far along. There's so much to absorb. So imagine somebody long in the tooth jumping into the business. What are the top 3 things that they should do? And you can't stop at 3. You're going to get to 90 before you even covered the turf.
Well, you saw what do you have? 398 pages just in that.
Yeah.
I mean, and some of the stuff I was looking at as you were going through it there, Frank, I was thinking, man, it doesn't really sink in until you see what you showed today, really how much is involved in automation. Right,
yes.
that a brand new technician to a facility, really just even the simple stuff, the things of understanding syncing and sourcing, and just the basic things that you hear about. You hear someone say PNP or NPN, I don't even know what the hell you're talking about, right? But multiply that times all the different things that you got covered in this. It's a ton of information. And of course, Frank, you've got what, almost 35, 40 years of all this knowledge right up there that you're trying to impart on the world. I mean, I give you kudos for that, man.
Well, it's, I think the best way to start after college, we both kind of did that. You get into, working for an Allen Bradley distributor, you're going to learn Allen Bradley really quick. And before that, I worked for Stevenson Controls, John Stevenson. I don't know if you remember him, but
oh yes,
he was another fountainhead of the old school stuff, the old clutch-based timers and the relays, and he was rebuilding a lot of that stuff. So it's stuff you absorb, and we've had mentors. You mentioned Tom Knoll Automation. He was the one who taught me really how to do CAD, because here I'm hand drawing a lot of the electrical drawings, and he's like, oh, here's how you use, Auto Sketch at the time. It was basically very cheap or free, and then we all migrated into AutoCAD, and then he left me behind and went to SolidWorks, right? Stopped doing 2D entirely, but yeah. Well, it's been great to talk to you, and good to see you again too, Dan, on a Saturday morning. It's, I don't know how many people want to take a day off, off when you're not normally working and come in. So I get different folks sometimes on Fridays than I do on Saturdays, but
I liked Al's contribution. And of course I had to turn my camera on when you mentioned Ali G. So
yeah, there you go.
I have to represent.
There you go. Yeah, she was a great guest. She's so outgoing and personable, involved in a lot of different things. So,
who is this?
Alicia Gilpin, Ali G. She's the lady building the turbo encabulator.
Okay.
Yes.
Okay. Gotcha. Speaking of turbo encabulator, one of the guys that works for Rockwell, he's out in California. He recently he's big time. He's got his own podcast series and everything. I don't know if you saw it, but he did an interview with the guy.
I listened to it. I did.
Retro. Yeah, wasn't that pretty cool?
That was very cool.
But my wife and I joke a lot about that retro encabulator.
Yeah.
That video, I don't know how many times I've shown that and gotten people looking, and they'd never seen it before, obviously.
The hyperbolic Marsal veins.
Oh, mercy.
Nice hand gestures.
That's right. That's right. So anyways, well, I'm going to hop off. I'll touch base with you here soon. It was great catching up with you, and we'll catch you later. Dan, great to meet you.
Nice to meet you, Al. Thank you.
All right. Well, thanks, guys.
See you later. See you, man. Bye.
All right. We'll see you.